Hello, students. I wanted to go over some breadboard basics with you. So breadboarding is a little bit of a skill, and most of you have probably never seen one before. So I'm going to just show you what a breadboard is and how it works. This is a typical breadboard. You can look at it and you can see a little plus and a little minus here. You can see the little A through E on one set of holes here and the F through J on this set. And you can see a repeat of the plus and the minus. It's probably useful to consider both of these halves here as completely separate entities. They're completely different. Each one of them has the same stuff. It's a mirror image. And this part in the middle is called the trench. And basically you could put a component across that. An integrated circuit will fit perfectly across that. So you can take a 555 circuit and pop that right across there, and it'll give you the timing that you need for a circuit or something of that nature. You can go right across that, and it's real useful. If you look at the sides here with the plus and the minus, those are called bus bars, right? So all of the holes in this column here are connected electrically. All of those in that column, all of them are connected electrically. So all of these guys here with the purple circle in them right now, they're all one circuit, if you will. They're all on, connected to one another. So that's useful because if I wanted to set up a circuit, I could just put a plus from a power supply going right into that positive lead and a minus from a power supply going right into minus, and it would provide me with a plus and a minus for any of these holes over here. When I look at those holes, those are labeled with rows 1 through 20, labeled A through E. You can see like this hole right here, right? That would be hole 1A. And hole 1A would be connected electrically to hole 1B and 1C and 1D and 1E. So all of these guys are electrically connected. If I go down a row to, let's say, a couple rows to 3, right, these are all electrically connected to each other. So if I plug something into one hole, it's the same as plugging it into any of these other holes. So those are all linked together. Of course, the trench is a divider. Nothing is linked across them. We're also not linking row 1 to row 2 or row 2 to row 3. They are not linked. If we took this entire board and flipped it over and peeled off the back, you could see that there's an entire connector that goes the whole length of there. And all you see in there are little clippies that hold the leads when you push them in there. They're like little spring-loaded metal pieces that hold the lead when it's pushed in there. These are exactly the right size for a 1/4 watt resistor to be driven into the hole and sit there firmly. There's also, I think it's a 22 gauge wire will fit perfect in there as well. So a couple different things. I usually use solid core wire when I'm working with this stuff. And you'll probably have a bunch of wire available that you can use there. There's little boxes that are full of jumpers that will conveniently use for this kind of project. So those are the basic ideas for what a breadboard looks like. All right, so typically you're going to see it in this horizontal orientation. That's the way that you're going to be setting it up for your work. That doesn't matter. Everything is the same. It's just turned that way. When we look at these examples, you can see that this circuit diagram over here is represented on the breadboard, right? So the power supply, the positive lead is coming in here. Right, there's your positive value coming in, and it's providing the positive power to this resistor that acts as a jumper here. You could put a wire there if you didn't have a resistor, but this is showing me that I have 3 1 kilo ohm resistors. So it acts as a jumper to bring you to the row. And then inside the row, since these are electrically connected, I don't need a jumper to connect these guys. It's connected in the back plane underneath. All these are connected, so I can plug my next resistor in here, span the trench, and plug it into the same row on the next side, where I plug in a lead from my resistor over here, and then I plug that lead in as a jumper across to my negative side here. So that creates a circuit, and I can have power running through my 3 resistors. I can do the same thing in parallel with a setup that looks like this. Again, the power is coming down these power buses, right? The plus is coming down through here. What we do in this case is we take a jumper cable, a jumper line. There's no resistance here. We just plug it right in there so that we're powering now this horizontal piece with my jumper. So it's providing power here. And then I take this other jumper and I provide power to another row. Now, since both of those rows are powered, I can plug in my resistors to those 2 rows and basically mirror it down here. And then I can connect those guys as well with the jumper, and then jumper back to my ground. And my ground is just going to go out just like we did before with our minus here, plus up here. And there's other ways you can do this, right? If you were trying to be tricky, you could connect that resistor right in there. Right? You basically draw it in there and then put it in here, and your barrel could be right here. And it would be doing essentially the same thing, right? You could have the resistor plugged in to the same row that it's in for here. It's exactly where the jumper is at in this case. That's electrically identical. So you're going to see this a lot, is that there's a lot of different topographies that would result in the exact same circuit being drawn, right? This would give us a third resistor essentially that would also be in parallel, right? Third component. And that's really all I'm showing here that I've done. Plugged in another component in parallel. You can do that. It's nice to do it in this orderly fashion, because when you're working with your breadboards, things can get out of hand really fast. You can start getting into more complicated situations. So in this case, you can look at a circuit board that's been filled up with a bunch of components. There's a little pot here that's a potentiostat, so it's rotating and it's changing the resistance there. This little light resistive element is going to see the light that's being shined on it, and it's going to change its resistance based on it. So it's like a light sensor. Here you have an LED. Here you have some kind of chip. I'm not sure what it would do. And here you have a, this is a transistor. And then you've got a couple resistors that are plugged in here as well. So all of these things are interesting because we can see that the bus bars are being used over here. That's where the power is going in, right? The negative lead going into the negative side of the bus bar, the positive going to the positive. And then these are immediately jumpered over to the other set of bus bars over here so that both of them are powered. Have to do that if you want them both to provide power to our circuits, right? That'll have to happen. And you can see how these are taking these particular rows and providing a way to go to ground here. Here it's taking a positive lead and going here and connecting to this pot to determine what the combined resistance is going to be. So you're going to build this kind of circuit in the future, and you should be aware that the neater you are on the work that you do, the better. That's why we go through and do our stuff without just jumping everything willy-nilly. If you're nice and orderly about this, using the jumper wires here and there so that it's neat, it's going to make it a lot easier to see how a circuit like this is actually behaving. What happens is you'll create this circuit and then it's not going to work. And then you're going to have to go through and figure out why it's not working. And doing that systematically is a lot easier if it looks nice and neat than if it looks like a jumbled mess. More complicated circuits like this one will require that you're really careful about what's going on. You're going to need to know which of the wires are hot, which have power, which are going to ground, and how it's all working. This also illustrates the point that you could have a completely separate board that'll be your output board, and everything that's happening here with the lights coming on is going to be an output. This is a 3-bit adder. So if you look at the 3 switches that are shown here and the other 3 switches that are shown here, you can change their state by pushing these buttons, and that's going to make 1s and 0s that go over here and get added to the 1s and 0s that are here. And using the logic of the circuits right here, they can add those two numbers together and give ones and zeros here based on the output that they should be to add those two numbers together. So it's a lot of wires just to do something simple like that. You know, it's a lot easier to have your calculator and just punch a couple numbers in. But this is a good way to investigate how the electronics works, what the digital connections are, and how you're going to create your own signals and process that and all that. Anyway, hopefully that helps you out. Thanks for watching, and good luck on your labs.